Now in this example, we're going to walk through it a little bit faster than we walked through the previous example of graphing an exponential function, because hopefully we're starting to get the idea of how these things work. So what I want to do first is I want to remember the fact that we said is that we can always start at the ordered pair 0, 1, because anything to the 0 power is 1, even though we have a fraction base here. So I'm going to scroll down over here and say, let me put an ordered pair at 0, 1. We at least know one ordered pair. And then every step I take to the right, multiply my previous y value by the base. That's what we were doing when we were looking at 2 to the x. We said every time I introduce a new x, the exponent increases by 1. If I increase the exponent by 1, what that means is multiply by the base one additional time. Let me repeat that. Every time we increase the exponent by 1, that means to multiply by the base one more time. That's not a super deep thing. That's the definition of what an exponent is. An exponent says this is how many times I multiply by my base. So if I increase my exponent by 1, then I'm saying multiply by the base one additional time. So as far as this problem, when the x value was 0, the y value is 1. So if I increase my x value by 1, then I'm going to multiply 1, I actually write 1 times. My base is 1/3, so I'm going to take the previous y value and multiply it by 1/3. That's 1/3. So I'm going to plot that. If I take another step to the right so that my x value is 2, I take my previous y value and multiply it by 1/3. That gets me 1/9. So I'm getting really close to the x-axis is what's happening here. And similarly, if I went to x equals 3, I would take my previous y value and multiply by 1/3 to get 1/27th. Really, I mean, at this point, I'm like super duper duper close. So we just know that we're getting close to the x-axis, but we are still decreasing. That's important to realize. Now, we'd also said on the last example that if I decide to go to the left instead, so let's write this out. So every step to the left, we said that we're going to multiply by one less version of the base. But to multiply by one version less means to divide. That's what division is. It's undoing multiplication. So if I take a step to the left, I'm going to divide my previous y value by my base. So going back over here, if I take a step to the left, that means I'm going to go to -1 from 0. My previous y value was 1. If I divide by my base, remember that division by a fraction is the same thing as multiplying by the reciprocal. So I'm really multiplying by 3. So my y value should be 3. If I take another step to the left where x is -2, then I'm going to take my previous y value and divide by 1/3, which means multiply by 3. And that gets me 9. And so I can see that if I were to take one more step to the left, my y value would be 9 times 3, which is 27. Now I can't put 27 on my graph, but it's important to know this value 27, because when I continue my graph, I don't want to make it look like this, where I'm crossing through at about 10.5. That would be wrong. I know that my graph should be really, really steep here, because I'm aiming up for 27, which is way off the graph. So it kind of gives me an idea of how steep my graph is to know that value. So as we look at these two examples that we just did, I want you to notice a couple things. So besides what we wrote as far as those 3 steps, I want you to notice that in both cases, these are one-to-one functions. They pass the horizontal line test. And we know that because in this case where we had a base that was a fraction, we were always decreasing. As you went left to right, you were always going downhill. So we're never going to pop back uphill to hit the same y value. Same thing when our base was bigger than 1, we are increasing. So as we are increasing here, we're never going to hit the same y value again. So we know that in either case, this is a one-to-one function, which is important so that we know there is an inverse. An inverse exists here. That kind of motivates our whole next lesson beyond this when we start to talk about the inverse of the exponential being the logarithm. Now also, I'd mentioned it already, but I just want to point it out again, that when our base was bigger than 1, we were increasing. We were going uphill. When our base was less than 1, we were going downhill. And that should make sense when we look at this second step here. That when to go to the right, we multiply our previous y value by our base. If our base is bigger than 1, then the y value is getting bigger. If that base that we multiply by is less than 1, then we're making that number smaller. So if your base is bigger than 1, you're increasing. If your base is less than 1, you're decreasing.